Inside an organization, we can no longer depend on our own. We need to communicate with others and work together to achieve common goals. It is similar to the majority of atoms. They interact with others to achieve stability. When they combine into molecules or compounds, they form molecular properties that are different from the property of its individual elements. One of them is the molecular mass. Mass is important to determine the new molecule's function and behavior. Today, we will discuss relative molecular and formula mass. Relative molecular mass. The majority of the air around us is composed of nitrogen molecules N2. To obtain its relative molecular mass, or MR, we're using the same formula that is used to calculate the relative atomic mass we've discussed before, which is the average mass of a nitrogen molecule divided by 1/12 of the mass of a carbon-12 atom. Just like relative atomic mass, the relative molecular mass is the more convenient number of the actual molecular mass in the form of a ratio, so it does not have a unit. But, unlike the actual mass, the relative molecular or atomic mass reflects the behavior of the atoms and molecules more accurately, because it includes the mass and prevalence of each isotope of the element. The quick way to obtain the value of relative molecular mass, or MR, is by finding the sum of the relative atomic masses, or AR, of all the atoms in its chemical formula. For example, carbon dioxide, another component of the Earth's atmosphere, has a formula of CO2. So, to obtain the MR of the substance, we need to add the relative atomic mass, or AR of carbon, added by 2 times the AR of oxygen, which gives a result of 44. Let's try to calculate the MR of sugar in sugarcane. First, we need to identify its elements. Then we multiply the AR of each element by their number, and lastly, add them together. This method works for molecules of other compounds as well. But for compounds that do not exist as molecules, enter the relative formula mass. Relative formula mass is only applicable to ionic compounds because they, namely sodium chloride among others, only exist as an atomically infinite lattice structure in a solid substance and individual ions in either liquid or a solution. Since we can't obtain the exact number of the constituent atoms, we cannot calculate the relative formula mass before we decide its chemical formula. From the lattice structure, the formula can be defined using methods that will be discussed in future videos. Then, just like finding the relative molecular mass, simply add the relative atomic mass of all the constituent atoms. Even for tricky substances such as the wonderful blue copper sulfate crystals, the steps remain similar. First, obtain the chemical formula from our giant lattice structure, which is CuSO4 5H2O, and then figure out the number of atoms in each element. Multiplying them with its respective AR and adding them all together give us the relative formula mass of copper sulfate crystals, 249.5. If you're confused, just remember that determining both the relative molecular mass and relative formula mass use the same equation. The only difference is that in relative formula mass, we need to obtain the chemical formula first before making the calculation. This is because the relative formula mass is the ratio for substances that exist only in ionic compounds, while the relative molecular mass is the ratio for molecular and covalent compounds. Now, to check your understanding, gypsum is the raw material to produce cast for supporting a broken bone. Does it have a relative molecular mass or relative formula mass? What is the resulting MR?